Shift register. So this is very important one. So we discussed about latch, flip flop, and types of latches and triggering of flip flops. Everything we discussed in previous videos. Now we are going to discuss about shift register. So before start the shift register, you know what is register? So register is nothing but it's also storage. We know you know that flip flop it can store one bit information. So register can store more than one bit. That means it's a combination that integrated flip-flop that can be stored as a register. So register means you know that here you know it's a storage device and it can store more than one bit. But you know that register shift register it can shift to the bit between the registers. That means it can shift the data from left to right or right to left, whatever it may be, but it's shifting the bits. That's why they are saying that's a shift register. So based on the shifting, they are split it into four category. One is serial input, serial output, serial input, parallel output, parallel input, serial output, parallel input, parallel output. So serial input and serial output. So this is the first one, first shift register. So serial input, serial output, serial input, serial. What you first of all we have to know what is serial, what is parallel. So serial means if you consider a ticket counter. So in the ticket counter, 10 people are in one counter. So it is like serial. That means only one counter is there, but 10 people are in that count. So the advantage is only one counter. That's advantage. The drawback is all the people come through this one counter. So this is serial. Parallel means so there are 10 people and 10 counters. So 10 counter is there. So 10 people also there, 10 counter also there. So advantage of parallel. Uh, so you have to make it 10 counters. That's a drawback. But advantage within a second and within the clock period, all the people are inside that counter. That means all the people are getting inside that particular place. So similarly, you have consider instead of counter wire, people they consider as a data. So 10 data and one wire is there that is serial. So the data have to come through this single wire. So here 10 wires, 10 data. So all the data each data having single wire, so they can come directly to the clock pulse. It can everyone come at a time. So similarly, here we are seeing serial input, serial output. That means only one wire. The wire is nothing but here. So this is the input and only one input and one output. So the wire is straight. Data is come. Data maybe you can give 1 1 1. So initially everything is zero. Here the clock pulse. So clock pulse means it's a negative edge trigger. It is a synchronous sequential circuit. So whenever the clock triggered, this one come to here, so it will be reflected in the output. Okay, but we haven't know whether where the output is there because output is here. The next clock pulse, so this one come to here, and the second one come to here, and third clock pulse, this one will be here, and this one will be here, and third one will be here, and fourth clock pulse here, and everything is coming like that, and last bit will be come here. Okay, so after fourth clock pulse only we see the output of this flip flop. So we see only one number one. Then fifth clock pulse, then it will be moved to here. So we got it next one. Then sixth clock pulse, seventh clock pulse. So after seven clock pulse only We have know what are the input given and what's output. So this is serial input and serial output. So this is operation what I say. So you see this. So one is there. So based on the clock pulse, and the second clock pulse, one travel to here and here. Then one travel to here and here. So like that. So this is the way that this is a truth table for the serial input, serial output. See. So this is a director of travel. And this is a waveform for serial input, serial output, and serial input, parallel output. So now we are going to see about what is serial input, parallel output. So serial input, parallel output means um, it is serial and this one is parallel. So the main advantage of serial input, parallel output, if it is applying again the same data. So first clock pulse here the one will be travel to here, but parallelly output is connected, so you can know where the one is available. So previous thing after four clock pulse only we got it output in serial output, but here within the clock pulse we can know where the one. Then second clock pulse the one is here, the next one will be here. So we can know two input. Similarly, third clock pulse one will become, so this one will here, this one will here, like that. So after fourth clock pulse, every one will be present. So within four clock pulse, we can know what is the output. But serial in serial output. So after seven clock pulse only you can know the what is output. But here within four clock pulse you know where is the output. Then serial input, parallel output. Serial input, parallel output. So, serial input parallel out based on the structures. Okay, we can achieve this serial input and parallel. That is we discussed just now. This is serial input, parallel output. Now we are going to see about parallel input, serial output. So parallel input, serial output. So parallelly they given. So within the clock pulse, just one clock pulse, all the inputs are in the flip flop. So second, the first clock pulse you will see the one clock one. Then second clock pulse you will be getting two, third and four. After four clock pulse you will see the output. But the main advantage is within the clock pulse all the devices are getting that input. That is parallel in serial out, and then parallel in parallel out. This is very speed, but you know that if the counters are more, the data will be come through the device. It is very fast. So parallel in means here. So this is parallel in. So every in there is one. So within the clock pulse, you will be get it output. So this is parallel in, parallel out. Okay, then bidirectional shift register. So it's a black diagram for bidirectional shift register. So bidirectional means, so we previously we see the data is moving left to right, so one way direction, and this bidirectional shift register can move right to left. So this is bidirectional shift register. Okay, so using this structure we can achieve bidirectional shift register. An operation, then universal shift register. Universal shift register means, so it can added every features of the shift register. Number one, it is bidirectional. Number two, uh, we can serial in, serial out, parallel in, parallel out. So both, some extra features are available in one single devices, that is called as universal shift register, like universal gate, NAR and NAND. That even within the gate we can complete any application. So like that, universal shift register also we can complete within this particular circuit we can complete all the application. That's why they're saying this universal shift registers. So it can achieve, see, parallel loading, left shifting, right shifting. So everything will be achieved. That is universal shift register. Thank you.